Today's video is a little bit more advanced than the previous ones, where we'll talk about the advanced notions of objects, the inherited methods by default, and the class string and string builder. Advanced notions of object in Java go beyond the basics of creating and using objects and involve concepts such as polymorphism, encapsulation, and abstraction. Encapsulation. This is the practice of hiding the internal details of an object from the outside world, so using like public or private keywords, and providing a public interface for accessing and modifying its state. So in Java, encapsulation is achieved through the use of access modifiers such as private, public, and protected, which control the visibility of an object's properties and methods. Let's take an example. Let's consider we have a class called employee and has private variables. At the same time, we have a constructor and some methods to get or to print some values, some variables of this object or of this class employee. And we have to create in the main employee, so an object of employee class, new employee John Doe with the arguments, which we'll call the constructor of employee. So it will initiate this name and this age and this salary to name, age, and salary of the arguments. And then we will create new variables, name, age, salary, calling the methods of employee, of object employee. So get name, get age, get salary. Why we should do that? Because name and age and salary are private in the class. So in the main class, we cannot see or we cannot print these variables. We cannot get these variables because are private type. And that's why to call or to get these variables, we should call some methods called getName, getAge, or getSalary. Inheritance. This is the process by which a subclass inherits properties and behaviors from its superclass. In Java, inheritance is achieved through the use of the extends keyword in the class declaration. Inheritance allows also for code reuse and abstraction, and enables the creation of complex class hierarchies. In this example, we have a parent class called animal that has a method called eat. Then we have a child class called dog that inherits from the animal class using the extends keyword. The dog class has its own unique method called bark, here. In the main method, we create an instance of the dog class and call the method eat, which is inherited from the animal class myDog.eat. We also call the bark method, which is unique to the dog class, here. This demonstrates how inheritance allows us to reuse code from a parent class and add a new functionality in a child class, like here we have the bark. This is the ability of an object to take on many forms. So in Java, polymorphism is achieved through method overriding and method overloading. So what is method overriding? It allows a subclass to provide a different implementation of a method that is already defined in its superclass. Method overloading allows the multiple methods with the same name but different parameter lists to coexist in a single class. Let's take an example. In this example, we have a parent class called animal that has a method makeSound. And then we have two child classes, dog and cat, that inherit from the animal class and override the makeSound method with their own implementation. In the main method, we create two instances of the animal class, one using the dog class and the other using the cat. Then we call the makeSound method on both instances, so animal1 and animal2, which will call the makeSound method of the appropriate child class based on the instance type. So here we call the makeSound of the dog, and here we call the makeSound of the cat. So this demonstrates polymorphism, where we can treat different objects as if they are of the same type, in this case as instances of the animal class, and call the same method on them but get different behavior based on their actual types, because the makeSound here is dog is barking and the other one is cat is meowing. Inherited methods by default. In Java, all classes implicitly inherit from the object class, which provides a number of methods that can be used in any object in the language. These methods are inherited by default in any class that does not explicitly override them. Here are some of the most commonly used inherited methods: toString, equals, hashcode, getClass, clone. It's important to note that while these methods are inherited by default, they can be overridden in a subclass to provide custom behavior. For example, this toString method can be overridden to provide a more informative string representation of the object, and the equals method can be overridden to compare objects based on their contents rather than references. Strings. In Java, strings are represented by the string class. This class is part of the core Java API and provides a wide range of methods for working with strings. Once you have created a string object, you can use the various methods provided by the string class to manipulate it. Some of the most commonly used methods include length, char_add, substring, index_of, replace, to uppercase. In addition to these methods, the string class can also provide many other useful methods for working with strings. One important thing to note about strings in Java is that they are immutable. So this means that once a string object has been created, its value cannot be changed. Instead, any operations that appear to modify the string actually create a new string object with the modified value. StringBuilder. In Java, the StringBuilder class provides a way to efficiently manipulate strings that may undergo frequent modifications. Unlike the string class, which is immutable and creates a new object whenever it's modified, StringBuilder allows for in-place modifications of strings. The StringBuilder class provides a number of methods for manipulating strings. Some of the most commonly used methods include append, insert, delete, replace, and reverse to reverse all the characters in the StringBuilder. That's all for today. If you liked the video, don't forget to subscribe.